Welcome back to the Inequalities unit. Today we're going to be talking about solutions to inequalities. So let's talk about exactly what a solution is first. So a solution to an inequality is any value that makes an inequality true. Most equations have only one solution, whereas an inequality has many solutions. So our example for this down there at the bottom says x equals 3. So when you're solving an equation that says x equals 3, 3 is the only possible outcome. However, when you have x is less than 3, like in an inequality, that means that any value less than 3, from 2 to negative 1,000, that's less than 3, is a solution to the inequality. So now let's take a look at that in practice at example A. So here at example A, it says circle all of the values that are solutions to the inequality. So the first thing that we need to do is solve the inequality and then see which solutions are going to match. So I'm going to start by drawing my wall down from my inequality symbol. Then I'm going to get rid of my constant by doing the inverse operation, which is positive 7 for my negative 7. Positive 7 and negative 7 are going to cancel, bring down my x divided by 2. I didn't multiply or divide by a negative, so my sign is going to stay the same. Negative 4 plus 7 is going to give me a positive 3. So now I've got x is divided by 2 is less than 3. Now I'm going to perform the second step, so I'm going to multiply both sides by 2 because the inverse operation of division is multiplication. These two are going to cancel, bring down my x. I did not multiply or divide by a negative, so my sign stays the same, and 3 times 2 is 6. So now that I have x is less than 6, I need to pick all of the solutions that are less than 6. So negative 8, less than 6, negative 5, less than 6, 1, less than 6, 3, less than 6. Now here's where it gets tricky. I have 6. So the question is 6 less than 6? And no, 6 is not less than 6, it's equal to 6. So since this is not true, 6 is not a solution to my inequality. Is 11 less than 6? No. Is 15 less than 6? No. 22 less than 6? No. And is 40 less than 6? No. So now I've selected all the solutions to my inequality. And notice there was more than one right answer here. So when it asks to find solutions, you need to find every solution to the inequality, not just one. Now let's take a look at example B. So here in example B, it says circle all the values of the solutions to this inequality. So this time again, I'm going to draw my wall down from my inequality symbol, and then I'm going to solve. So I'm going to subtract 15 from both sides to get rid of my constant first. Positive 15 and negative 15 are inverses. They're going to cancel each other out. Bring down my negative 10n. I didn't multiply or divide by a negative, so my sign stays the same. And then negative 75 minus 15 is going to be negative 90. So now I've completed the first step. The second step of my problem is to divide both sides by negative 10. The inverse of multiplication is division, so I'm going to divide both sides by negative 10. Negative 10 divided by negative 10 is going to give me positive 1 or positive 1n. I did multiply or divide by a negative in this case, so my sign is going to change to the other side. And then negative 90 divided by negative 10 is going to give me positive 9. So my solution to this inequality is n is greater than or equal to positive 9. So now I need to circle all the numbers that are greater than or equal to 9. So negative 9, not greater. Negative 4, not greater. 0, not greater. 6, not greater. But now I've got positive 9. So the question is positive 9 greater than or equal to 9? And yes, it is, so that is a solution to my inequality. 14 greater than or equal to 9? Yes. 22 greater? Yes. 80 greater. So again, I found all of the solutions to my inequality, and this time 9 was included because it asked for things that were equal to. And since it was equal to 9, it was a solution to my inequality. Now let's take a look at example C. Here at example C, things are a little bit different. It says circle all the sets that match this description. So we have to have sets in this case. And it says all values in the set are solutions to the inequality. So again, when we have sets, we have to make sure that all of the numbers in the set are solutions. We can't just have some in and some out. All have to be solutions. So before we figure that out, we need to start by solving our inequality. So we're going to draw a wall down from our inequality symbol. Then it looks like we have the distributive properties start here. So we're going to distribute the 3 to the 2, the 3 to the negative a. So 3 times 2 is 6. 3 times negative a is going to be negative 3a. Bring down my 51, I didn't do anything with that, and bring down my inequality symbol. The next thing I'm going to do is subtract 6 from both sides because that is a constant. The inverse operation of positive 6 is negative 6. These are going to cancel, bring down my negative 3a. 51 minus 6 is 45, and I did not multiply or divide by a negative, so my sign is going to stay the same for now. And the final step of my inequality, I'm going to divide both sides by negative 3. The inverse operation of multiplication is division. Divide both sides by negative 3. These are going to cancel, bring down my a. This time I did divide them by a negative number, the negative 3, so my sign is going to flip, go the other direction. And then 45 divided by negative 3 is going to give me negative 15. So the solution to my inequality is a is greater than or equal to negative 15. So now that I have that, I need to make sure that every number in my set qualifies as an answer. So is negative 20 greater than or negative 15? No, it's not. And since it's not, all the other numbers in my set do not matter. As long as I have one thing that is not correct, the entire set is incorrect. So on the next one there, I have, is 0 greater than or equal to negative 15? Yes. Is negative 4 greater than or equal to negative 15? Yes. Is negative 17 greater than or equal to negative 15? No, it's not. And since that one is not, we cannot count the entire set. Let's take a look at the next one. Negative 15 greater than or equal to. Yeah, greater than or equal to. It is equal to, so that matches. Negative 1 is greater than, and 6 is greater than. Since all three numbers in the set match, this one is a correct answer. And the last one we check is 3 greater than or equal to, yes. 7 greater than or equal to, yes. 10 greater than or equal to, yes. And since all three match, then the entire set is correct. So notice when we're talking about sets of solutions, every single number in the set has to be a solution for the answer to be correct. Now let's take a look at example D. Here we are at example D. And example D says circle all the inequalities for which 6 is a solution. So in this case, they've given a solution and we need to figure out which inequality matches it. There's one of two ways to do this. We can either solve each inequality and figure out if that matches 6, if the description of the solution matches 6, or we can plug 6 in and then simplify to see if it turns out to be a true statement. We're going to do both. The first one we're going to do our standard solving. So we're going to go ahead and draw our wall down from our inequality symbol. Then we're going to see that we have variables on both sides of this inequality, so we're going to have to move one of them. I'm going to move the positive 5x. It doesn't matter which one you move, but I don't like dealing with negative coefficients, so I'm going to get rid of the positive, or get rid of the negative. Negative plus positive is going to cancel, bring down my 9. I didn't multiply or divide by a negative, so my sign is going to stay the same. 5 plus 3 is going to be 8x, bring down my minus 7. The next step in my inequality is to get rid of that constant, so I'm going to add 7 to both sides. 9 plus 7 is going to be 16. I didn't multiply or divide by a negative, so my sign stays the same. Bring down my 8x. The final step in this inequality is to divide both sides by 8, and I get these are going to cancel. I didn't multiply or divide by a negative, so my sign stays the same. X is less than or equal to 2. So is 6 less than or equal to 2? No, it's not. So this one is not a correct answer. Now let's take a look at the second one, and this time we're going to use the substitution. So this time I'm going to take my negative 2, plug in 6 into my inequality. Minus 6 is greater than 18. So let's see if that works out now that we substituted in. So we're going to follow our order of operations. 6 minus 6 is 0, so I'm going to end up with negative 2 times 0 is greater than 18. Negative 2 times 0 is 0. Is 0 greater than 18? That doesn't appear to be accurate, so therefore this one is not going to be correct either. Now let's go down to the bottom one. Again, I'm going to do my substitution here, so I'm going to plug in my 6 for the x, minus 7, greater than or equal to negative 2. 6 divided by 2 is 3. 3 minus 7, greater than or equal to negative 2. 3 minus 7 is going to be negative 4. Negative 4 greater than or equal to negative 2. I don't believe that is correct, so this one is not a correct answer either. And the final one we'll go ahead and solve. So we're going to draw our wall down from our inequality symbol. Subtract 3 on both sides. These are going to cancel. Bring down x over 6. Bring down my inequality symbol. I didn't multiply or divide by a negative. 4 minus 3 is 1. Now I'm going to multiply both sides by 6. The inverse operation of division is multiplication. And I've got x is less than or equal to 6, because 1 times 6 is 6. Is this true? Is 6 less than or equal to 6? Yes, it is. So the correct answer is the last one. But notice I had to go through all of them, either plugging in 6 as my solution or just solving my inequality and seeing if it matched. That brings me to the end of example D, so let's go ahead and take a look at the last example. Here in example E, it says circle all the inequalities for which this set of solutions is true. So every time -3, 1, and 6 have to work in order for this to be a solution. Now we could plug in -3, plug in 1, and plug in 6 to each one of these inequalities, but that would take a lot of time. So it's a lot easier to just solve each inequality and see if each number will work in your solution. So the first one, we're going to draw our wall down from our inequality symbol. Looks like we have distributive property, so we're going to distribute our -4, distribute to the -3. -4 times x is -4x. -4 times -3 is going to be +12. Bring down my inequality symbol, bring down my 9. Now I've got a regular two-step inequality, so I'm going to subtract my constant. +12 and -12 are going to cancel, bring down my -4x. I didn't multiply or divide by a negative, so sign stays the same. 9 minus 12 is -3. And now we're down to our last step. We're going to divide both sides by -4. We did multiply by or divide by a negative, so our sign is going to flip. And -3 divided by -4 is going to be +3 over 4. So our solution to the first one is x is less than 3/4. So we have to check if each one of our numbers is less than 3/4. So is -3 less than 3/4? Yep, that works. Is 1 less than 3/4? No, that doesn't work. Is 6 less than 3/4? No, that doesn't work. So this first one, is not a solution. Now let's take a look at the second one. We're going to draw our wall down from our inequality symbol. Looks like we've got variables on both sides. I'm going to go ahead and move this -4x because I don't like dealing with negatives, but you can move either one. -4x and +4x are going to cancel. Bring down my 30. Bring down my sign because I didn't multiply or divide by a negative. Bring down my -18. And 4x plus 4x is 8x. Now I've got a regular two-step inequality, so I'm going to add 18 to both sides to get rid of my constant. -18 and +18 are going to cancel. Bring down my 8x. Bring down my sign. I didn't multiply or divide by a negative, and 30 plus 18 is going to be 48. Now I'm going to the last step of my inequality. I'm going to divide both sides by 8 because the inverse operation of multiplication is division. 8 divided by 8 is 1, or 1x. I didn't multiply or divide by a negative, so my sign stays the same. 48 divided by 8 is 6, so I've got x is less than or equal to 6. So now we need to check each of our numbers. Is -3 less than or equal to 6? Yes, it is. Is 1 less than or equal to +6? Yes, it is. Is 6 less than or equal to 6? Yes, it's equal to. So all three work, so the middle one is a correct answer. Now let's go ahead and take a look at the last one. So we're going to start by drawing a wall down from our inequality symbol. Now it looks like we have a regular two-step inequality, so the first step here is to subtract 3 from both sides to get rid of our constant. They're going to cancel. Bring down the -2x. 1 minus 3 is going to be -2. I didn't multiply or divide by a negative yet, so my sign stays the same. Then I'm going to divide both sides by -2. The inverse operation of multiplication is division. Divide both sides by -2. Since I did multiply or divide by a negative, in this case my sign is going to flip. -2 divided by -2 is going to be +1, or +1x, and -2 divided by -2 is going to be +1. So now we need to check all of our answers. Is -3 greater than or equal to x? No, and since the first one's wrong, we know the rest of the solution will not match, and we figured out the middle one is the only correct answer. So that brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.